Hi students, we are looking at section 2.8, quadratic linear systems, and those are systems of equations, meaning more than one equation, and the solution is where the equations meet or intersect. And we are going to be solving these by graphing, and so let's look at the possible solutions. So no solution, so perhaps right? A quadratic, that's going to be a parabola. And the line for linear, it might look like this. Here's my parabola, and then off to the side here is the line. What's super important about this is that it's not a line like this. Let's be real. Where is this line heading? And so you have to remember that lines continue, and so if it does, you're going to want to keep graphing. So something that would obviously never meet, for example, there's that large amount of space between the line and the parabola. Another type of solution would be one solution, and so that could be as easy as here's my graph, and then oh my gosh, here's my line, perfectly tangent. Or perhaps my parabola looks like this, and then there's just a beautiful point of tangency on another location. So that would indicate that there would be one solution. And again, the solution is going to be an ordered pair, x comma y, where the two are equivalent. And then, of course, a parabola and a line could meet at two locations, and there would be two solutions. So this is the type of picture that we are expecting, and we're going to use all of our skills to graph these functions. And since we're looking for the solution, we're going to be very clear about our ordered pairs. So you might notice a little change from your note guide. Please make that change on these equations. So looking at the first equation, it is a line, and I'm going to translate that to y equals mx plus b. So step one is going to be subtracting 3x. So it'd be negative 5y equals negative 3x plus 5. And then dividing everything by negative 5. And I'm going to have y equals positive 3/5 x minus 1. So I start at negative 1, I count up 3 and over 5, up 3 again and over 5. And then I'm trying to get as many specific ordered pairs as possible. And so I'm going to go down 1, 2, 3 and over 5, and down 1, 2, 3 and over 5 again. And let me scroll down so you can see that. Oops. And then for the next equation, it's my parabola. Let me remind myself of the parent function. So the parent, remember we have negative 2, negative 1, 0, 1, and 2, and then I have 4, 1, 0, 1, 4. So that's my parent function, and I'm going to identify my key features A, H, and K. So A is 2, and then my HK is going to be 6, 0. And so let me actually do this one in another color. So I'm going to have my parabola, and it's x plus 6, and then AY plus K, so 2y. So negative 2 plus 6 is going to be 4. Negative 1 plus 6 is 5, 6, 7, 8. And then 2y, I'm going to have 8, 2, 0, 2, and 8. Awesome. So let me plot these ordered pairs. 4, 8. Here's 4, and here's 8. 5, 2, winner, winner. 6, 0, 7 comma 2, and then 8 for x and 8 for y. So I'm going to pull. Okay. So I got one of my solutions for sure. Let me write that down. It's 5 comma 2 because I found that was where they were intersecting. And I have to sketch my line. I should have connected these dots. Okay, and so now I have to approximate my solution. Notice this word here, approximate. So we love to end up with perfect ordered pair solutions like the 5, 2, but that's not always the case. So I'm going to estimate what I think this solution is. So here's 6, 7, here's 8, so it's very close, not quite in the middle, so I'm going to call it 7.3, comma, and then it's most of the way to the top, so I'm going to call it 1, 2, 3, almost 4, so 3.8. And that is my estimate. So I'll put my little tildes right there. So very cool. I found one very easily. It was one of my ordered pairs. And then the other one, because I was on graph paper and I had kind of done a good job sketching, I'm hoping that that was pretty close to the solution. Okay, cool. On number 2, we have a line that is in point slope form. And so I can see that the slope is -3/4, and that the point is 3 for x and then -3 for y. So for that one, I'm going to start at the ordered pair, 3, -3, and then I'm going to count down 3 and over 4. And then I will count up 3 and over 4, up 3 and over 4 again, up 3 and over 4. And I'm going to remember to connect these dots. So, drawing my arrows. Oh, dang it, I pushed something in it. Gosh, I sure wish I had a straight edge, but not on a computer screen. Cool. Now let me graph my parabola. So again, I want to remind myself of the parent function, -2, -1, 0, 1, and 2. My y values are 4, 1, 0, 1, 4. And here I can see I have the hk of -3, -3, and the a value is equal to -1. So I do x minus 3 and then -y minus 3. So -2 minus 3, -5. -1 minus 3, -4, -3, -2, -1. And then -4 minus 3, -7. -1 minus 3, -4. -3, -4, -7. Okay, so -5, -7, -4, -4, -3, -3, -2, -4. Oh, Lordy, what are we seeing here? So, they didn't meet. No solution. There were no solutions to this equation. They will never meet because of the direction of the arrows pointing down. So, cool. That's what that looks like. All right, we have one more example here. So my first equation is the parabola in this case. So, reminding myself of the parent. And then I have my A is equal to 0.5, and then my HK is 0, comma, -4. So that will make this one kind of easy. It's just going to be X, right? Not plus or minus 0. And then 0.5y minus 4. Okay, cool. So -2, -1, 0, 1, and 2 unchanged, and then half of 4. Half of 4. 2 minus 4, -2. Half of 1 is half. Half minus 4, -3.5. Then -4, -3.5, and -2. So let's see what this gets me. -1 and -3.5. Here's 4, 3.5, 2. And then I kind of want to have another ordered pair here. So because I have the 0.5, I want an even number. So I'm not going to use 3 because 3 squared is 9. 9 is not even. So I'm going to try -4 and +4, which are 16 each. So I'll have -4 and +4. So so then I've got the 16. So half of 16 is 8. 8 minus 4 is 4. And so I'm going to have -4 for x and +4 for y. And then +4 for x and +4. And I'm doing this just so that I have a few more ordered pairs. And I'm using the fact that it's y equals x squared for my parent. So let's connect these. Okay, cool, looks pretty good. And now I'm going to switch over to graphing the line. So this line is right here. And I have an m of 2, and then my ordered pair is 2, -2. 2, -2, hello. Yes. 2, -2 is a solution. And then if I go up 2 and over 1, I'm right here. Up 2 and over 1. Up 2 and over 1. Up 2 and over 1. So I'm getting further away on that side. I go down 2 and backwards 1. Down 2, backwards 1. So when I go to connect my dots, woohoo! I got a tangency. So I just have one solution on this. Oh, very cool. Very cool. So this was our last example. And that's it. So have fun on your homework. Goodbye.